We are looking at measuring segments. So anytime you see a notation like this, AB, this is talking about the length of the line segment AB. So we are looking at the length of that line segment AB. AB, when we're talking about the length of it, it's actually the distance between those points A and B. So it's the distance between points A and B. Or another way to think about it is what we're actually doing is we're looking at the absolute value of the value of A and minus B. And the definition of absolute value is actually the distance between 2 points, or the distance between two numbers. So this is the absolute value of that. Remember, absolute values always ends up being positive because it's a distance. We can't have a negative distance. So let's look at an example. Here I have, well, what is AB? What's the length of AB? Now you could maybe look at it, and in this case we have a number line, and count it out. But let's look at using our absolute value to describe that. So we write our absolute value signs. A is at the number -4 minus B, which is at the number 3. Absolute value acts like parentheses, so we do what's inside of there. 4 minus, or -4 minus 3 is going to be a -7. We still have our absolute value. Remember, the absolute value of -7 is the positive, or how far away that is from 0, which is 7. So the distance of this is 7. Now, just like we said, we could count this out in this case because we have a number line, but it's 1, 2, 3, 4, 5, 6, 7. So that's a way that we could check our answer. But I don't want to draw a number line each time I do these and count that out, where we can just use the absolute value to get that length. Another thing that we can do with line segments is we can do some addition. So notice here I have A and B, and I have the line segment BC, and altogether that makes the line segment AC. So what we can do with that is I can say, well, if I have AB, I know what AB is, and I add it to BC, that's going to get me, so if I take this part right here, AB, and I add it to this part right here, BC, that's going to get me my total length, which is AC. So if I said this was 3 and this was 7, 3 plus 7, the whole length of that is then 10. So let's look at an example. Now this example actually goes beyond just giving 3 and 7 like a number, but now we have little expressions here. This is one of the things that we're going to be doing. If I have an expression for each of them, and I know the total length, so EF is 8x minus 14, FG is 4x plus 1, but I know EG, the whole length, is 59. So we know EF plus FG equals 59 because it equals EG, or this whole length. Now we take our parts that we know, 8x minus 14 and 4x plus 1, and we can put them together to figure out what x is, and then we can figure out the length of EF and FG. So let's do that. EF is 8x minus 14 plus FG, which is 4x plus 1, and that equals that 59, or EG. Now all we have to do is combine our like terms and solve for x. So we're using some algebra with this. This, because the x's are both on the same side, all we do is combine them. 8x plus 4x is going to be a 12x. And then think of this as a negative 14 plus 1 is going to be a negative 13 equals 59. Now we're at the point of a two-step equation. So we add 13 to both sides. We can draw the line down if that helps. Think of it as a minus 13 or negative 13 plus 13 cancels out. We're left with 12x on this side equals 59 plus 13, which is 72. 12 times x, so we undo the multiplying and we divide. 12 divided by 12 goes away. We're left with x equals 72 divided by 12, which is 6. So x is equal to 6. But we're asked to find EF and FG. So all we do is replace x with a 6. So let's do that over here. I have 8 instead of x. I'm going to put a 6 in, minus 14. 8 times 6, and this is for EF, I should write that here. 8 times 6 is 48, minus 14. 48 minus 14 is going to be a 34. So EF is 34. Now looking at FG, FG is this 4x plus 1, so 4 times x, which is 6, plus 1. 4 times 6 is 24, plus 1 is 25. We can check this now too, because those two added up should equal 59. 34 plus 25 does equal 59, so it does work out. All right, let's look at a couple of more on our second page, if you'll flip the page over, and talk about congruent segments. So we've talked just a little bit about congruent, but congruent means that things are the same. And so a congruent segment are two segments that are congruent if or when they have the same length. So all they have to do is have the same length. And so to represent congruency, we use this little symbol. I'll write it small here to fit in there, but I'll write it bigger too. So it looks like an equal sign, and then it has just this little squiggle above it. That tells it that it's congruent. They have the same length. So like if I had AB here, 1, and said that was 1, and CD, which had also a length of 1, those would be congruent. So we would say line segment AB is congruent to line segment CD. Moving on with that, we can kind of add this to a midpoint. And remember, a midpoint is a point that divides two segments into congruent segments. So it cuts it in half, essentially. It's a point that cuts the segment in half into two equal segments, or congruent segments that have the same length. And the point, line, ray, or segment that goes through that point, we call it the bisector. We're going to be kind of talking about that throughout this. So it's our bisector. Bisector meaning like the bi is cutting in half, or two in sector. So it's cutting it into two sections that are equal. So we can look at an example of this one, similar to where we had expressions in the first example. We have expressions here as well. Now this one is saying that Q is the midpoint right here. This part, PQ and QR, have the same length because it's the midpoint. It's dividing into two congruent segments. So these two are the same. 6x minus 7 equals 5x plus 1. So we can set up an equation with that because we know that these two are the same, or another word for the same is equal. PQ is then congruent or equal to QR. Our equation then is going to be 6x minus 7 equals 5x plus 1. Now I have an equation we can solve for x, which will help us find those two lengths. This case, because our x's are divided by the equal sign, I can't just combine them, and we have to use our opposite operations. I want to get my x's both to the same side. I see this, so I'm going to move this x over here. I'm going to subtract 5x from both sides. Those go away right here. 6x minus 5x is 1x, or just x. We have our minus 7 equals a 1, or plus 1. I want to get the x all by itself, so we do the opposite here, and we're going to add 7 to both sides. These go away. That leaves me with x equals 8. So we know x is 8. That will let me figure out these two. And this is really a good way to check our answer as well, because whatever I get for here should equal what I get for here. So PQ, remember, is 6x minus 7, but x is 8. So it would be 6 times 8 minus 7. 6 times 8 is 48 minus 7. 48 minus 7 is 41. Doing the same thing for QR, which is 5x plus 1. So 5x is 8 plus 1. 5 times 8 is 40 plus 1. 40 plus 1 is 41. We got the same answer for both, which is good because these are supposed to be congruent. Now, the biggest thing to be looking for is when we're working through these is you're going to get them mixed up. Are we going to set the equations equal to each other like we did here? Or are we going to add them and then set them equal to some number? The key thing to look for is, do we have a midpoint or bisector? Are the two parts, are we told that they're equal or congruent? Or are we saying these two pieces add up to something else? And that's the key thing to look for. Here we're told the whole thing. If you're told what the whole thing is equal to, you're most likely going to be doing something like this. If you're told that you have a midpoint, you're going to be setting them up equal to each other and then solving like this.